Okay, hello Honors 2. This is lesson 6 for us, and actually the last two lessons, 6 and 7, are going to be sort of on the same ideas, right? So if you look at the title up here, right above this stuff, it says proofs and equations filled, right? So really we're going to be talking about proofs and equations for the next 2 days. Then we'll have a review day, and then you guys will have your test, and we'll be done with both the unit and the year. So kind of hard to believe, but that's where we are. Okay, let's get started. One thing I should mention too is some of the stuff today will be using graphs. I'm going to try and use Desmos on here, but you guys can use Desmos if you're at home. We really want you to know how to do stuff on the calculator. Unfortunately, I don't have an emulator for my calculator right now, but please write your teachers if you have any questions about using stuff on the calculator or how to use your calculator to do the things that we ask you to. Okay, let's go back to the mouse. So first thing up here, formative quiz. We do not have one of those, so I'm going to just scratch through that. Okay, and like I said before, here's the aim. What are some different ways that we can solve trig equations? We've talked about this already, but we'll continue to emphasize that because it's a massive topic. And we'll also do some trig identity proofs. Okay, and when we get to these, I'll talk about the difference between prove and show that. Those of you that are going to IB courses, you'll see show that every once in a while. And you'll see prove also, and those are different command terms. Okay? If you're going to AP, you don't really need to worry about the difference, but it's good practice for you to be comfortable with your algebra and your overall trig knowledge. Okay, so page 2 here. Solving a second degree equation using an algebraic approach. So, okay, we're going to do this purely algebraically. Our equation is 2 sine squared x equals 1 minus sine x. Like I said before, use an algebraic approach, and here we have a limited amount of values of x that we want to look at. So we are going to, I'm going to write it here, we're going to solve for, in this case, a particular solution, right? So again, particular solution means we have a finite set of answers. Okay, we'll look at some later, I believe, where we have to write the general solution. That's a formula for all the possible answers. And with a lot of trig equations, that's an infinite amount. The other thing is it says to give the solutions as exact values. All right. So let's see here. We like, if you remember from before, we like the same argument in our equations, our trig equations. So we have x here, and we like the same trig function. So we have sine x squared and sine x here. That's nice. Okay, so all we have to really do is manipulate this, get it in a form that we can solve, but we shouldn't have to use any trig stuff. All right, so this equation is the same as saying 2 sine squared x plus sine x minus 1 equals 0. Okay, so all I did is I took these two things, moved them over. So added the sine, that's here, subtracted the 1 that's here, and we got it set equal to 0. You guys should be thinking now, this is a quadratic, right? So I'm going to let u equals sine x, and then our equation turns into 2u squared plus u minus 1 is 0. I'm not sure, but I think that's going to factor, so I'm going to set it up like that. And yes, it will if we do plus 1 minus 1. There's our factored form. Okay, so sure, let me change color. So this means that u is equal to either a half or u is equal to negative 1. And our u was sine. So sorry guys, it's probably being annoying, but I'm going to go back. So this means that either sine x equals a half or sine x equals negative 1. Okay, and again, this is unit circle stuff, so we should know these values. We're in radians, so in this first equation, right, this equation here on the left, sine x equals a half. That means x is either pi over 6 plus or minus 2 pi k. And I guess I can scroll down. Yeah, I got some more room. Or x is 5 pi over 6 plus or minus 2 pi k. All right, so visually, there's pi over 6. There's 5 pi over 6. And at both of these at both of these angles, the sine is a half, right? This is like 30 degrees, the sine of that triangle. We're going up a half over 1, up a half over 1. Okay? And the plus or minus 2 pi k is to capture all the answers. So this is actually a general solution. This is how I do it. I'll modify that to get the particular solution later. The other part, sine x equals negative 1. So that only happens at one place, right? That's when we're straight down. So I'm going to write that as x equals 3 pi over 2 plus or minus 2 pi k. Now, whoops. Some of you might say, oh, straight down is actually negative pi over 2, which is absolutely correct. So this could be negative pi over 2 plus or minus 2 pi k, right? Doesn't matter for the general solution, but we want a particular. So if I start taking these values, so I'm going to start with pi over 6 here. That is in our set of possible answers. So I'm going to say pi over 6. Now if I subtract 2 pi from pi over 6, I'm below 0, so that's not going to work. If I add 2 pi to pi over 6, that's going to be bigger than 2 pi, so that's not going to work. So really, this is our only answer from this general equation, general solution. Same thing here. 5 pi over 6 plus 2 pi is too much. Minus 2 pi is so much. There's too much. And I guess I should mention, remember, k here, guys, is always, always, always an integer. We're never adding half the period or anything. Okay? So 5 pi over 6 is the second answer, and then 3 pi over 2 is our last answer. Okay, so in this case, these starting values are all within this domain, right? If we're adding 2 pi or multiples of 2 pi to it, or to those, we're going to be outside this range, okay, this domain. So these are only 3 answers. And if you started with a different value, like for example, if you start with negative pi over 2 here, that first one wouldn't work. You could add 2 pi, and then you would get 3 pi over 2. Okay, so that's our answer. I guess I'm going to highlight because I selected it. So there's a solution to page 2A. All right, the second or third page, second question, but it's really the same, right? This is the same equation, but it says use a graphical approach. So one thing I thought of, if we rewrite this, we could say, I think, sine x is equal to 1 minus 2 sine squared x. All right? So all I did is I took this negative sign and moved it over there by adding it. I took 1 and subtracted the 2 sine squared x, got this. All right? And that really, on the right, turns into, if you remember, cosine 2x. All right? So one way you could do this is you could graph this equation, sine x. Hopefully you know what the graph of that looks like. You could graph cosine 2x, and you could see where they cross, right? And again, you're only looking for places that they cross on this interval 0 to 2 pi. All right. I did something different. And what I did, I'll show you in a second. But I just took this, I graphed it in Desmos. I took this, I graphed it in Desmos. And we'll look at what the answers are there. So graphical approach, especially if you're trying to do it by hand, you might change the equation first. But I didn't want to do that. So here's Desmos, right? I don't think I can write on or use the laser pointer on here. So right in this equation 1, I've got 2 times sine x squared, right? So that notation, sine x squared, that is the same as sine squared x, right? Remember that. So 2 sine squared x on Desmos, I'm putting in as 2 sine x squared, okay? Then here's 1 minus sine x. Okay, I adjusted the window in Desmos. If you guys click the wrench here, you can kind of change here and here what you want the x values to be. So I'll show you what I mean. So for example, I could put in 0 here. And one cool thing too, is rather than having to find the pi sign, you can just push 2 and you can type in the letters pi and it'll convert it to pi. Okay, the y-axis here I didn't change. I could, maybe I'll do that. Let's go from like -2 to +2. Okay, and you can also, if you want, change the step, make that 1. All right, and then as you can see, I had to drag it to see more of the graph, but we want to know where does this thing cross. So pi over 6, that's 1 point. 5 pi over 6, that's a second. 3 pi over 2, that's a third, I believe. Yeah, that's what we got here, right? Yeah. Pi over 6, 5 pi over 6, 3 pi over 2. Okay, so that matches. That's a good check. And a lot of you guys use, Desmos as a check for your algebraic work anyway. Okay, so state the general solution. So that's part B. Let's finish part A. So I'm going to just say from Desmos, x can be pi over 6, 5 pi over 6, or 3 pi over 2. So those are our answers, and those I believe are the same as before. Yeah. All right. General solution. Well, we actually already did that. The general solution is here, and here, and here. Okay. And maybe we can see it. The thing is, if we continue to scroll, right, here's another answer. Here's another answer. Here's another answer. And, let's just say, let's let the x-axis be 100. Probably not a good idea, but all right. So we're going to get tons of points where these things cross, right? So it's going to be hard to find. 25 pi over 6 is one. 121 pi over 6. You see a bunch of these. So there are an infinite amount of answers. It's not fun to write an infinite amount of things. So the way we simplify stuff is by adding in that period multiplier. So here we could say x is pi over 6 plus or minus 2 pi k, 5 pi over 6 plus or minus 2 pi k, and 3 pi over 2 plus or minus 2 pi k. And, the minus is important because we could go in the opposite direction, right? Desmos, I was just going to the right, but let's see if I can scroll. Yeah, I mean, we could just keep going forever to the left and, keep finding answers. There's one, negative 139 pi over 6. Okay? So, here is our general solution. All right, one more and then I'll stop and make a second video to break this up. So, one of the reasons we use graphing is because sometimes you're going to get ugly answers, right? So, in this case, you got to solve it numerically with a GDC because we're not going to be able to know the trig values that produce a certain number, right? We're not going to know the angles. So this says use a graphical approach in the zero feature of the calculator to find the solution to the equation blip. Give answers to the nearest tenth. Okay. It doesn't say general or particular, but we'll see. So I'm going to put this in a Desmos, right? And you guys can use your calculator. I think you all know how to find zeros, but like I said before, I don't have a calculator on my iPad, so I've got to use Desmos. So x cubed minus x squared. Okay. So we've got x cubed minus x squared that's one equation. And I think the other one, yeah, let me go home. The other one I believe was 2 sine x. Yeah. Okay, so 2 sine, and this is what I like about Desmos too. You just type in sine, it'll recognize it. 2 sine x. Okay, so we can kind of see from here, I guess, that because of the nature of the green graph, right? There's only going to be there's only going to be a couple places where there are answers. So one is here, one is here, and one is here. And actually, you know what? It said use the 0 feature. So let me redo this equation. I'm going to, instead of having 2, I'm going to take this and I'm going to subtract 2 sine x, because that allows us to use the 0 feature. Sine x. Okay, and actually, look, it's easier to see the answers, right? Because you're just looking at where does it hit the x-axis. So there's 1. That would be negative 0.9. That is 0. And this is 1.7. Negative 0.9, 0, 1.7. Can I remember that, guys? Can I remember that? X equals negative 0.9, 1.7, or 0. Negative 0.9, 0, 1.7. And I guess if we wanted to, sometimes IB will ask you to do this, but you could just draw a rough sketch of the graph, right? You could say, oh, the graph looks something like this. That is the graph of x cubed minus x squared minus 2 sine x. And we've got 3 answers. All right. 1 here, 1 here, 1 here. And I guess if we wanted to, we could just highlight. There's 1 there. That's not really to scale, but you get the idea. Okay. Negative 0.9, 0, 1.7. Yeah. All right. Let's keep going. You know what? I said one more page, but I guess I'll just start with this. So the last couple examples are proving identities. I'll continue with this. So read through these, right? Read through these, and we'll go over them in the next video together. And then we'll look at, we've got, I think, just 2 to prove. Yeah. So not too lengthy today. All right, guys. See you very soon. And I'm going to go a little bit longer because I realize that this video trims before I kind of want it to. All right. See you in the next one.